Hi, this is a problem which is to maximize some function z equal to 4x1 plus 3x2 plus 6x3 subjected to the constraints 2x1 plus 3x2 plus 2x3 less than or equal to 440, 4x1 plus 3x3 less than or equal to 470, 2x1 plus 5x2 less than or equal to 430, and x1, x2 and x3 are greater than or equal to 0. See, this is a problem which is formulated as a LPP from a given set of conditions. So in this problem we will now see how to solve this using a simplex method. In simplex method you have to write this in the standard form, in which you will not be having any all the right hand side of the conditions has to be positive. Then there will be no inequalities in the constraints, and also you will be having maximization function always. So first we need to check whether this is a maximization function or not. This question is obviously to maximize z, so there's no issue with that. Now we have to incorporate slack and surplus variables so that this inequalities has to be changed into equalities. So here you can see the standard form of the equation because we have three inequalities for this. We introduced S1 here, S2 here and S3 here, and these inequalities changed to equalities. These S1, S2, S3 are called as slack variables, which we have dealt earlier. So max z is equal to 4x1 plus 3x2 plus 6x3 was the original equation. We introduced three slack variables, but the values of coefficient are 0. And again here we can see that this first equation is inequality is made into equation by introducing S1, and other twos are 0. And here there was no term of x2 here, so we changed that to there was no term of x2 here, so we just introduced 0x2 here. Like this, we have S2 here and 0s1 and 0s3 equal to 470. The inequality changed to equality by introducing this S2, and similarly we can have this 0x3 here, 0s1 here, 0s2 here and S3, and change this inequality changed to equality. So after writing this standard form we can just find out an initial basic feasible solution by so we have only three equations, so three equation has to go, and which are the non-basic solutions. So in order to find the initial basic solution, we put x1, x2 and x3 equal to 0, and we have the corresponding values from the equation 1. We can have s1 equal to 440 because the other terms will become 0, and from the equation 2 this equation you will be able to obtain s2 equal to 470, and from the third equation you will be able to obtain s3 equal to 430, which serves as the initial basic feasible solution. And with this we will go into the iteration. See, the equation was its previous form. It was 4x1 plus 3x2 plus like that. Okay, so we have to introduce these variables here: 4x1 plus 3x2 plus 6x3 plus 0s1 plus 0s2 plus 0s3, and the basis is x1, x2, x3, s3. And here also we have chosen three basic variables, s1, s2 and s3, and their corresponding coefficients we'll write it here as cb. And the three equations which 2x1 plus 3x2 plus 2x2 x3 plus s1 plus 0s2 plus s3 equal to 440, which comes here, and the second equation coefficient will be written here, and the third equation coefficient will be written here. Then what we do is we find out Zj, which is summation of Cb into Aj. So which means for finding out this value, what you have to do is you have to multiply corresponding elements of CB with this x1. So 0 into 2 plus 0 into 4 plus 0 into 2 will give you this. It's obviously 0. And similarly this value can be obtained by multiplying CB into 3 plus 0 into 0 plus 0 into 5. Obviously it is 0. And similarly we can obtain all these values. And after that we have to calculate capital Cj is equal to small cj minus zj, which means you have zj here and cj here. So this 4 minus 0 will give you this 4, this 3 minus this 0 will give you this 3, 6 minus 0 will give you 6, and so on. After that we have to find out whether this is optimal solution or not. If it is an optimal solution, all this will be either negative or 0. There will be no positive values. Here we have 3 positive values, which means this is not an optimal solution. So we have to go on iterating it. In order to iterate it, we need to find out which variable is coming in and which one is going out. So what we have to do is, in order to determine which variable is coming in, we have to find out the maximum of these values. That is, here it is 6, and this corresponds to x3. So the next iteration, this x3 will be coming in, and in order to find out which one is going out, you have to divide this b by this value, these x3 values. And so 440 by 2, 470 by 3, and 430 by 0 will be the theta values. And you can see that the minimum one is 470 by 3. So this will be the incoming variable, that is S2 is the outgoing variable and X3 is the incoming variable, which means the intersection we will be having the pivoting variable here. So in the next iteration we will be having this S2 replaced by X3. This is the next iteration. So what we have to do is we have to have this x3 here, s2 is replaced by x3, and the corresponding coefficient will come here. Everything remains same here, but what we have to do is, in the previous table, this is the 3 is your pivotal variable. What you have to do is you have to make this 3 equal to 1 and the column, all the columns elements 0. So what you have to do is you have to divide this x3, this is the position of 3, and in order to make it 1, we have to divide the entire row by 3. So this 4 become 4 by 3, 0 remains as such, 3 become 1, here is 0, this 1 become 1 by 3, and 470 become 470 by 3, and then you have to make this 0. It was earlier 2, so this 2 has to be made 0. You can do row operations. This was 2 here, so by doing the row operations, this 2 minus this row into 2 by 3 will give you the value. When it comes here, 3 minus 0 into 2 by 3, so it remains 3. When it comes over here, this 2 minus 4 into 2 by 3, and here it is 1 minus 0 into 2 by 3, this is 0 minus 1 into 2 by 3, and like that. So the remaining the values will become minus 2 by 3, 3, 0, 1, minus 2 by 3, and 0. Similarly, this has to be made 0, but fortunately this value was already 0 for S3, so we don't have to work on that. So we will copy down the values from the previous table, and then this B also has to be the same thing will be applicable here for B as well. So 440 minus 470 by into 2 by 3 will give you the value here. This 430 will be coming as such because it's already 0. So it will become 380 by 3, and this remains 430 itself. And then again you need to find out, after writing this, we need to find out this whether this is optimum or not. In order to find out, we need to find out Zj. Like in the previous case, Cb multiplied by minus 2 by 3, so 0 into 2 by 3 is 0, 6 into 4 by 3 is 24 by 3, 8, and 0 into 2 is 0, so the sum is 8. Again here, 0 into 3 plus 6 into 0 plus 0 into 5, which results in 0, and here 0 into 0 plus 6 into 1, this is 6, plus 0, which comes as 6. Similarly you can complete this one, and here also you can do the same. So this yields us 940. Again you can check for optimality whether there is any positive value. So here 3 is the positive value, there is only one value, so that has to come in, which means x2 has to come in, and in order to find which one is replaced, so here we need to divide these values by the corresponding term. So this is 3 here, so 380 by 3 divided by 3, it is 380 by 9. This is 470 by 3 divided by 0, which is infinity, and 430 by 5 is 86. So considering these three, this is the lowest one, so S1 has to go and x2 has to come in, which means 3 is the pivotal value here. Again we go for another iteration by replacing this S1 with x2, and here is a table. Here we have all these values x1, x2, x3 like that. So here we have replaced this 3, this x2 will come here and the corresponding value 3 will come here, coefficient in the objective function. Again we do what we need is we have this is the x2 and s1, this is the first, or is the pivotal value. So this is our pivotal value. We will make this 1 and this as 0. Same row operations we will do, and we have the corresponding values 380 by 9, 470 by 3, 1970 by 9, and correspondingly 3200 by 3. And we will check for optimality by calculating this I, this 3 multiplied by minus 2 by 9 plus 6 by 4 by 3, 6 into 4 by 3 plus 0 into 28 point, this 22.3. and similarly we can find out all these terms, and Cj is the value xi. Sorry, I don't have this. This is 4, 3 and 6 here. So 4 minus 22 by 3 is minus 10 by 3, and we will calculate all these values and see that all these are negative, which means this is an optimal solution. And the value, the corresponding value is here 3200 by 3 is the maximum Zi value corresponding to this set of values. So what we do is we will have the final solution. So x1 is 0, x2 is 380 by 9 and 470 by 3. This x1 is not in this analysis, which means x1 is 0. Whatever is not here in this analysis is 0. That means x1 is 0, s1 is 0 and s2 is 0, and only x2, x3 and s3 is having values. So x2, the corresponding value is 380 by 9, x3 is 470 by 3, and s3 is 1970 by 9, which is not relevant because it is not the variable which we are seeking for, and z is 3200 by 3. So taking this x1 is equal to 0, x2 is equal to 380 by 9 and x3 is equal to 470 by 3, z max is 3200 by 3, and the numerical value is 1066.67. This is how the linear programming problems can be easily solved by using simplex method. Thank you for watching. Take care.